Okay, like I said, next video, I have 3 examples for rational equations. Rational equations, you can see right here, have expressions with the variable in the denominator, such as that x right there. That's rational. It doesn't graph a line. It's not linear. It's not quadratic. It's rational. 2 things about solving a rational equation. The denominator can never equal 0. So I know you learned way back when that any number over 0 doesn't exist. But if you had 0 over a number, that would always be equal to 0. So remember that 0 can never be your denominator because you can't eat 3 pieces of nothing, right? You can't grab 3 anything out of nothing. It just doesn't make sense. So in a rational equation, 0 will never be your denominator. So therefore, we do things such as restrictions. You have to set those. So the first thing we do when we're solving an equation, a rational equation, we have to find out what x can't be. So x cannot be anything that's going to make either one of those denominators equal to 0. Or if you want to look at it this way, x plus 1, which is one of the denominators, can never be 0. So therefore, you subtract 1 from both sides, x could never be -1 in this particular problem. So first step is set your restrictions for x. Then try to solve it. We learned in, I think it was 1.1, how to clear fractions. So if you didn't learn it then, you're going to have a problem now. That's the best way to do these harder equations. Just clear out those denominators. So you have to figure out what your LCD is going to be here. And the idea is to clear out your fractions. So you need to set up your LCD as whatever's going to clear those out. So the only thing that's going to clear out of 4, or the smallest number that will clear out of 4, is a 4. These binomials can get kind of tricky, so if you talk to yourself, talk your way through it, you can figure it out. The only thing that will cancel out or divide out in x plus 1 is x plus 1. So it's really easier than it looks. It's pretty obvious. You got to have those. So 4 times x plus 1, just multiplying them together, will give you what your common denominator needs to be. So then, just like we did in 1.1, or for this last test, multiply every term by your common denominator. And then each denominator will 0 out or cancel out. So the first thing to cancel would be the 4s. So remember, whatever you have in the numerator, what's left over, you multiply them together. So that gives us the x plus 1 that was left over from the least common denominator times what's in the numerator. You got a big fat minus sign there. So let's do it again. X plus 1 is in this denominator. So those would divide out, and we're left with a 4 times 2x. And then, I'll erase that and make some room. We don't have a denominator here. Well, it's 1, right? But 1's not going to cancel out. So we multiply all of that together. And I'm going to rewrite it like we're accustomed to seeing it, kind of standard. Now looks like a linear equation. So let's solve it just like we would any linear equation. So we have to multiply those two binomials. So FOIL method would be 4x squared plus 3x plus 4x plus 1 times 3 is 3. All of this would be minus 8x, and then we can multiply through 4x squared plus 4x. Let's clean it up, which would be those like terms. 4x squared plus 7x, 7x, we have another one, don't we? 7x minus 8x would give us a minus 1x. So all three of those are gone, plus 3. So after you clear your fractions in this initial step, you start just cleaning it up, but you have to go carefully because you can mess up some signs. Now, we've got 4x squared, we've got a quadratic term, so we're going to try to solve as a quadratic. And I know to do that because of the x squared terms, and in 1.4, that's what we studied. So the first thing to do would be set it equal to 0, right? That was that zero factor property. So let's subtract a 4x squared and subtract a 4x there, so I'll have 0. But if I take a 4x squared away from here, I'll take it away from here, and it zeroes out that x squared term. Subtract the 4x, subtract the 4x, and I end up with a negative 5x plus 3 equals 0. So this is just linear now. Linear, solve the linear equation. So if we subtract a 3 from both sides, we end up with x equal 3/5. So we have to check as our final step. We said in our restrictions that x could not be negative 1. Well, since this is not negative 1, we're okay with that answer. So it gets a little intense, but with practice, and I mean practice, you should be able to do it easier. Let's do the second one. If you see that you can factor that denominator, it's going to work a lot better if you go ahead and factor it out, because you're solving for x, not x squared. So in the denominator, when we know we want to look for an LCD, we need to factor it if we can. And that's just simply the difference of two perfect squares. Hopefully you can see that. X minus 1 times x plus 1. Okay, let's get started. Remember, find your restrictions for x first. So right here, what would keep this denominator from equaling 0? If x were 1, 1 minus 1 would make that 0. We can't have that. So x can't be 1. Here, what plus x would make that denominator 0? And I hope you can see that would be a negative 1. And here the 1 and the negative 1 still ring true. So we're done with that step. Second step, number 2, LCD. I need an x minus 1 in my least common denominator to clear that. I need an x plus 1 here. And here you have both of them. So I think it's safe to say that x minus 1 times x plus 1 is going to be my least common denominator. So remember, multiply everything times your least common denominator. Kind of running out of room there. And then clear fractions. So over here, let's clear our fractions. And once we do that, we have x minus 1. That clears out, and we're left with all of that. So x times x plus 1. X plus 1's clear out, and we're left with minus 1 times x minus 1. And then this whole denominator clears out, and we just have a 2. And just start cleaning it up. Let's distribute the x through. Here there's an understood 1, so be careful. Distribute the x, or the negative sign, and then negative times a negative 1 is a positive 1. X's 0 out. Let's say you can subtract a 1 if you want to and have x squared equal 1. And extract square roots. X equal positive 1 and x equal negative 1. Because 1 squared is 1 and negative 1 squared is 1. This is a quadratic. So instead of moving 1 over and factoring difference of 2 squares, I chose to just take the square root of each side. But you have to check with restrictions. Don't forget that step. Because this says that x is 1. Well, we set the restriction that x can't be 1. Because if it were, it would make this not make sense or undefined. Negative 1 is also in the restrictions. So actually, there is no solution to this one. And that means that this combination does not work. So no x value would ever work for that. So this side, for whatever x could be, will never equal that side. It's just a faulty equation. Just doesn't work. And then lastly, let's do one more. Because this is kind of a difficult concept and you've got to practice it. All right, so here let's set our restriction. And it looks like the only thing x can't be is 0 itself. Because 0 squared would be 0 and vice versa. Common denominator is going to be x squared. You can use x cubed if you thought it was right, but x squared is going to be better. The x squares cancel. One of the x's cancel. Subtract 7 from both sides. And it looks like x is negative 1 over 19. And I need to go back and fix this. That's a 6x squared, isn't it? I'm making my own mistakes. All right, let's set it equal to 0 by moving over 19x, and that's 7. And I hope you find by slide and divide method, hopefully there's not an issue anymore with your factoring. You'll find that this is 2x minus 7 times 3x plus 1. Set each factor equal to 0. We're solving this just like a quadratic with two solutions. 3x equal negative 1, x equal negative 1/3. X cannot be 0, so these solutions work. That's it for the rational equations, and I'll see you on the second video solving radical equations.